Yo, what's good, y'all? You Dub back here again in 2022. Let's get it. And in the past, I've talked about what I say is actual evolution. Um, we're going to be getting more into that here again in some of these videos, just like I often do with different ones. I like to keep things rotating, keep things um, in different sectors. Like that's how I get down with my own life with research, and I like having different discussions. I don't like stuff getting boring. As far as on the channel, I don't like the same like just white stale bread and whatnot. And the thing is, when I talk about actual evolution versus what a lot of people talk about, is that even in biology, um, a lot of agendas are being pushed, a lot of rhetoric, a lot of dogma, a lot of narratives, if you will, are talked about. And if you start looking into the supposed science, there's a lack of empiricism, there's a lack of logic in a lot of cases. It's a lot of pseudoscience, a lack of hard data and hard facts. There's a lot of speculation, a lot of just assertion, assumption, and I can go on and as a critique. But in this video, obviously, we're talking about, you know, the aspects of evolution and what the different types of evolution actually are. And mind you, even though I'm mentioning this mainly for biology, this is true of political evolution, it's true of social evolution, it's true of cultural evolution, it's true of evolution in pretty much every regard of the term. So keep that in mind when we're having this discussion that these aren't just, byproducts of mechanical, biomechanical, bioorganic uh, systems or abiotic systems, right? Non-living systems. These are products of what evolution actually looks like. Now, if you were to ask in simple terms, what is evolution? It's simply change over time. But just keep our, and again, we're mainly focusing on biology in this specific video. We can address other aspects later. Um, but what if you were to give a more detailed, a more adequate, if you will, and a more precise definition of evolution? It would be the natural forces that influence change in the environment in conjunction with organic entities adapting over time. Let me say that again. I know that's a mouthful. The natural forces that influence change in the environment in conjunction with organic entities adapting over time. Now, what that translates to in simple terms, okay, if that's a little bit odd, is that there are forces outside of biological means, right? There's the forces, let's say the forces of nature, the laws of nature, the laws of physics. You could say the laws of mathematics if you want to go into these outside forces. If you would think of like a terrarium or aquarium, things like that. These are the outside factors. These are the control factors, if you will, that you know utilize power that kind of direct different aspects um, towards change. Otherwise it would be not so much. And change is an interesting thing, and we'll get into what that entails in these different types of evolution. But change isn't this drastic thing necessarily. Change isn't that things, because we'll address stagnation being one of them. It's not this overhaul. It could be seemingly, as long as it's not completely static and in stasis, it's change. So change can be both benign or malignant. It could be relatively indifferent, but it happens. Okay? Um, Similar to like symbiotic relationships, they're not all just this major shift. And unfortunately, when you hear evolution talked about, there's always this major shift. Even if they say they're using it as an excuse, as if time itself is magic and it just dictates things. That's not how things work. So as we were saying that these outside forces influence in the environment, in the biome, in the different habitats, etc., in the different ecosystems in conjunction with, and because this is an issue that I have with a lot of people that try to talk about the origin of life, try to talk about biogenesis and things of that nature, is that they just say, well, just one point, this just boop, and then here we go. No, in conjunction with, in alongside with the organic entities themselves, the biological aspects, adapting over time. So that would mean that there would be outside, again, that would be necessary material then, you know, forming to the changes in the environment. The atmospheric pressure, the hydraulic cycle, the phosphoric cycle, the nitrogen cycle, um, the electrons, the protons, the neutrons in the surrounding area and within the body. You know, if you try to go underwater, well, that's a different barometric pressure. That's a different depth perception. You know, different aspects with eyes, things like maybe a sickle cell uh, being adapted to fight off certain things like malaria. Okay, just different aspects that can occur. Now, there are, initially I think of like about six different types, 5 to 6 different types of evolution, but there are about 10 I describe. And again, a lot of these aren't even really talked about, or they're just assumed as a part of stuff. And when you're talking about these kind of broad topics, or these very, very particular and fundamental things, we need to be as specific as possible so that we can be accurate in our assessment of matters. Okay. First of all, we have progress, what we typically consider evolution. Okay. Now, progress is things which push forward. Okay. Progress doesn't necessarily mean entirely benign, though. It doesn't necessarily mean entirely beneficial. What determines beneficial, or at least beneficial from the aspect of what people deem? You know, oh, this is beneficial because we had success in this area, but it destroys in these other ones. Is that necessarily progress? Again, we can have that social and cultural discussion later. But in the case of what I mean by progress, for example, if you have a species, right? And also evolution, by the way, the three forces is isolation, adaptation, and natural selection. Natural selection, adaptation, and isolation. Um, and I usually talk about those in different ways. We can get more into those specifically at another time. But natural selection deals with reproduction. Who mates with who? This notion that reproduction is this, this mystical kind of thing, and then the best genes will. No, they won't. Who mates with whom is what the genes get passed down. So sometimes, depending on, because let's say the female, women, select 95% of the time, whatever the genes get passed down are the genes that get passed down. If she's not necessarily with, you know, from a physically superior and intellectually superior, if he doesn't have the best means of resources, doesn't have the best means of whatever, then she's selecting a mate that's possibly defective. Now, I'm not hating on people's choices, but let's be real. We can see some of the people, they are not the genetic best replication. Somebody with Down syndrome, for example. This isn't a shot. This is a reality. This is a genetic abnormality, right? That doesn't mean that the person can't live a good life. Blindness, deafness, uh, paralysis, genetic neurological defects. Okay, these are things that are passed down via, a lot of times, a dormant via the mother. Also, if the dude, You learn this, as you trying to spread your seed, as they say. But the man needs to also be cared if you really only care about that. Also, genetic compatibility. A lot of things have been messed up with birth control and more that we can talk about. But what genes get passed down are massively important to the survivability of the offspring. And if we actually played by those games, certain men would be selected more or be sought after that aren't being sought after. And again, we can have that discussion at another time on what that actually indicates. Adaptation, ability to change with the factors towards survival in an environment and what that looks like in different regards. And again, isolation. You take and you put a species in an environment for an extended period of time away from any other interactions with either ones of their own species or limited interactions with other species and other forces of nature. Okay, so progress, getting back to that, progress is literally doing aspects that will make one successful towards one's environment. For example, giraffes. Why do giraffes have long necks? Well, giraffes have long necks because at a certain period of time, the trees that had these specific leaves or whatever that it's eating were higher. And the ones who had the short necks are dying off. The ones who had the longer necks had the more advantageous aspect of survival. So, thus, reproduction with those longer necks. Um, a lot of times, these aspects are encouraged if from a natural sense because it's like the woman's like, ooh, big, strong, protect children, mate with you. Ooh, flashy, depending on the species. Ooh, flashy, peacocky. Social, good. Mate with you, better offspring. Simple stuff like that. Okay. Adapting to the environment. Uh, if, for example, you have, let's say, the Samoans, right? And we can get into things later with them, but the warriors who could survive the long voyage, maybe they were bigger at the time, but those fat deposits and different things were able to survive the long voyage. So those were who the women got with, as well as stronger could deal with the type of weapons and stuff. And again, we got another video that's coming up that's going to address more of those factors. But yeah, that's just an example. Warfare and those aspects towards the progression in that regard. The bigger, stronger, tougher, faster, or maybe the endurance, the type of fighting that's done. When comparison to certain hunters who, they utilize spears and stuff and it affected their warfare. Again, we'll talk about that later, but that's an example of progress towards a certain end. Moving on, number 2, de-evolution or devolution. De-evolution, again, I mentioned about the benign or malignant. De-evolution is still evolution. It's change adapting over time. If, for example, in order to survive, the species grows shorter, you could say, oh, well, why is taller a better evolution? Because height typically indicates that you are from a more lack of nutritional deficiencies. Okay. So if a species, in order for it to survive, is shorter because the nutrients or the food sources um, dictate that in order to survive, you need to have these genes just to be able to survive. You're still surviving, but it's shrinking because of nutritional deficiencies over time, and the average height will shrink. For example, if let's say a certain type of wolf, why the wolf or the horse will be leaner in this section of the world versus over here is because the leaner ones are the ones again who survive and who are passing on their seed, but they're not necessarily the most optimal. So over here, the horses or the wolves are big, strong, and tough and would take out if it was a straight up fight, for example. And this is why genetic diversity is also a thing, because, and a good thing, and why isolation becomes bad, things like inbreeding and more, because you have this survival, but the best genes are not necessarily being passed on. While over here, you have a combination of the best genes. Maybe over here, the skinnier has developed a certain, I don't want to say isotope, but a certain gene factor, to where it's good and hardy with the metabolism. But over here, it mates with the horse or the wolf, and that aspect of the strength, the speed, and whatever is also being developed. So hopefully the offspring, with, if it's not in the first generation, maybe down the line, both genes are passed on in the gene pool, and then we can have like a super wolf or a super horse, right? So that kind of happens. But de-evolution over time is the product of the best traits being affected and hindered. And usually 1 to 2 generations isn't bad. But once you start getting into 3 to 4 generations, you develop a pattern. Even in scripture, in the Bible, it talks about, and I will curse you into the 3rd or 4th generation. People don't understand all of what that actually means. And we may have to do an entirely separate video on what that actually indicates and all the ramifications of that. But this is the kind of thing, is that the genetic curses that are done, the generational curses that are done. Now, moving on to number 3. Again, I mentioned stagnation or gradualism. Stagnation is like a pond, okay? Stagnation means, and folks, when we colloquially will talk about stagnation, is that it's nothing actually changes. It stagnates. It's not true. On a more nuanced approach, and again, we'll talk about culture at another time, so because social stagnation is a little bit different from biological stagnation because of the amounts of time that we're talking about. But with biology, we can look at, just like with history, we can look at a broader perspective. So biological stagnation will look like this. Let's say it's a pond, right? Now, a pond, and we'll deal with the plant, the pond scum, right? Because the pond doesn't have moving water, moving fresh water like a river, and a river would be, rapid change over time. That it's very slow, very relatively static environment. And I said relatively, it still does affect, and especially if you have a flooding situation, or if you, um, would have a landslide affecting the pond or whatever. But if it's left to its own devices, there will be certain species that develop, and only certain types of species that could pretty much survive in that environment, because nothing really happens to impact it, good, bad, or indifferent. And the stagnation or the gradualism is such a slow process of change that it's almost not noticeable. Things do happen though, but they're on such an decreased amount. It's like putting time. Like if you were to play a game like Civilization or Age of Empires, and you put that thing on, instead of there was a rapid like a cheat code or a certain map to where it's like things are moving through the ages very, very quickly, or the normal speed. Imagine you were putting that at like super slow speed, to where you're in the Stone Age for like an hour or two before you switched ages. Like it took forever to gain the resources. Well, what would happen? You would adapt to that type of warfare. You would adapt to that type of living. You would adapt to that type of environment. And that's all you will ever know. And that's all multiple generations ever know. So that changes your, and this is where not only just time, isolation will do this as well. If you have, or again, inbreeding, any time when any of these factors, these 3 major factors of natural selection, adaptation, and isolation, are massively taken to the extreme, you will get stagnation, and it will massively impact how uh, a species develops. Whether it be, again, progress is looking towards a specific end and effect in a positive light typically, but just affecting towards a growth of something. While de-evolution is a kind of a reductionary aspect of it. It's not entirely reduction, but it's towards survival that's not necessarily the most optimal, but it is necessary. This one is just gradual changes over time that we pretty much see for an extended period of time. So it's as if you go back in time because we don't know, or we can see things more towards their primal state potentially, or their ancient state. Certain species are like this actually, whether it be in like reptiles or closer to some of it, or certain plants, certain bacteria, things of that nature. And so it'll be like, oh, well, this was like it was millions ago. Yeah, because it's just been in the same type of environment, or it's just hardy enough to where it doesn't really change. You know, humans are, or Homo sapiens are one of the best at adaptation. So thus, humans change over time so much. And that's the thing. Like a lot of people say, oh, there were all these species and subspecies of Homo. Maybe, maybe not. Again, we can have that discussion or debate at another time. But I would argue that it's really just been Homo sapiens. We just are really good at adapting to our environments. Moving on with number 4, mutation. Now, most mutations are malignant. They're malign. They're bad. But there are some that are benign. And then there are indifferences. Things like sickle cell, as I mentioned earlier, where it's the question of, okay, yeah, this doesn't necessarily good with the genes, but would you rather live 40 years and reproduce, or would you rather die pretty much in childbirth or early childhood? See what I mean? Mutations, you'll have sometimes with eye color. Some of them are very, very minor. Some of them, but they're mutations. These are abnormalities. Okay, I mentioned about Down syndrome, for example. It doesn't mean that someone is necessarily bad or good. It's just there's something that's outside of the norm, the abnormal. Even in intelligence and stuff. So it could be something that seemingly, but it goes against what is the base state at that time. Mutations are fascinating, and again, we can have an entirely different discussion on just that alone. I'm pretty sure most of y'all know about the X-Men and things like that. They do have they play it up obviously in a fantastical, accelerated kind of thing, but really think about the X-Men and how the different genes and how that would impact the environment if you're having people with different abilities and different stuff develop because of biological factors. Like let's say a Bobby Drake, for example. In a more tame version, Iceman Bobby Drake, he's able to deal with extreme heat and extreme cold. That's a mutation. Let's say Storm. She's able to again deal with extremes with electricity and things of that nature. Maybe she would be able to even channel these kind of things. That's a massive mutation aspect that would affect with her children, and if that gene's passed on, how that would impact. Um, a Cyclops, a Scott Summers, that, maybe not eye beams, but, you know, his eyes are super sensitive in a lot of different ways. So that he would need to put on different types of shade and stuff, right? Completely functional in every regard. And you can look at each of the X-Men on Tame thing, and I might do a video on that, to where actual mutations from their seeming power sets you could, derive certain things from. But moving on, number 5, symbiosis, right? So symbiotic relationships, there's more than 3, but there are typically 3 that we talk about: mutualism, commensalism, and parasitism. Again, there's more types of symbiosis, but in those specifically, mutualism is there's a dual exchange of benefits towards both partners, okay, towards both, let's say, what is it? certain type of fish, let's say one protects and the other cleans off of it. Then there's the type of commensalism where one party benefits, the other is just not affected. Let's say, the clownfish and the sponge. Like the clownfish is protected, or not the sponge, but the anemone. Anemone, all right, or however you say that term, y'all know what I'm talking about, where the clownfish may go and it's around that and is protected from others because of it. And then there's the parasitic relationships with like a leech on something, and something's, being detrimentally affected, and the leech benefits. All right. Symbiotic relationships develop over time. And again, this is more so than just one species in isolation. These are where multiple species are interacting simultaneously. And again, you can have this in a cultural, political, and social aspect, but this is where stuff starts getting fun and complicated when it comes to biology. Moving on, because we can have an entirely different discussion on symbiosis. Counter. So counterevolution, all right? This is more so looking like there is something in the environment that is forcing something to have a complete opposite reaction. For every action, there's a complete opposite reaction from a physics standpoint. This is where remember I talked about the stagnation? This is like the complete opposite of the stagnation, of the gradualism. This is something of an event so drastic. Let's say a meteorite hits in an area, and it completely disrupts the atmosphere, it completely disrupts the landmass, it completely disrupts the supply chain or whatever. You have to develop. Or let's say there is a virus, a massive virus, and certain antibodies, like, people die off, and you just have to develop herd immunity. You have to develop certain things, or a certain type of bacteria is released into the environment that is so detrimental that it hyper accelerates an evolutionary factor. Counters can come in all different things. It's when, instead of slowing down a factor, you've massively introduced. For example, 3 different ways. Let's say instead of an isolated population, right? You now introduce multiple types all at once. That counter will produce all kinds of offspring. We don't know what the effect will be, but boom, now you having all these different types of babies. So the gene pool just accelerated massively. Adaptation, I mentioned about certain natural factors, that virus, bacteria, or a meteorite hitting, drought, um, you know, starvation, just a prolonged drought. Not too long, but the initial shock of the drought versus, let's say, it's a kind of barren land for a while in a harsh environment to where they would adapt over it. But no, it's just like it's gone a severe drought for like 3 years. Well, that will impact depending on the lifespan of the species, and just isolation. Well, the opposite of that is, again, hypothetically, this big meteorite, the small one, crashes where there was a mountain. That mountain's gone. And let's say that mountain affected not just the geology, but the meteorological patterns. Well, you just taken that out. Now what? Right? So that kind of aspect, right? Moving on, we have rarities, isolated variables. These are fun because these are where, and I mentioned like the X-Men, these are where the anomalies happen. There's no accounting for them. And it's actually, when it comes to, from a social aspect, and again, we can deal with this another time in another video, but when it comes to a social aspect, you don't really account for these. It's hard to deal with these types of people. There are people that have different thoughts, people different ways and whatever, and you just looking like, and I don't mean just the people who are odd, like these are more so the odd people. These aren't the people who are out here doing wild shit, right? These are people who are like, they just look different, right? Um, I don't mean like a different racial ethnic aspect. I mean more so like someone is like really, really long limbed. Okay. Someone has a extremely long neck. Someone's eye, like say most people's eyes are here. Someone's eyes are out here, and you just like, oh, okay. Um, someone has, let's say the majority of the population is like black and brown hair. This person has fiery red hair. Just very rare things. And it can go in different ways. It can cause it to where there's rejection, but it can also cause it where there's honestly obsession, and fanaticism because it's like, ooh, ooh, that's different. It's like even though made it not racial or ethnic, sometimes though this is why people will because they don't know they don't think maybe it's the pheromones or whatnot. It's like normally people say people get with their own, sure, but interracial, for example, relationships are maybe there's something within that particular person or those particular persons that are like they're interacting. Let's say someone like myself likes someone who's blonde hair or whatnot, and just that's the most attractive, or maybe it's the genetic compatibility. Maybe it's something in my genes and that person's genes and that woman's genes that it's just like the lighter complexion, fairer complexion in mine. Well, maybe my genes are like ooh genetic diversity as opposed to someone who looked more similar to me, maybe the genetic compatibility aspect. And maybe it's just, or maybe generationally, after so many generations, it's just like, yo, we need diversity up in this bitch. And it's like, think about the British soldiers who went, when they were sailing across the globe, and like Captain James Cook, and they were like, oh my gosh, these Polynesian women, we ain't never seen anything like this before, kind of thing. You know what I mean? So it's not necessarily a bad thing. It's just, oh, there's that attraction to that rareness, that specialness versus what you can get on the average. So again, evolution is a funny thing. It's not this one size fits all kind of aspect, and all these factors will change things drastically. And you normally don't have multiple. You might have some of these simultaneously, but you don't really have all 10 of these. But I'm just presenting different points in time, different factors that you may run across. Number 8. Dominance, dominant versus recessive genes. This is more so genetic factors in this regard, although you can extend it to other aspects. For example, dark hair is a genetic factor that is dominant. Light hair is recessive. Blonde, red hair, these are recessive genes. This is the simplest ones. Eye color. There's a few eye colors. I believe blue eyes are a recessive gene, and other ones like that. So you get those. Those are pretty much ones that are talked about. If you've taken any basic genetics class with human anatomy or biology, you know this kind of thing. I'm not going to bore you with that one. There's plenty of videos that talk about it. Moving on, number 9, retroactive slash regression. Now, I mentioned about in stagnation and de-evolution about these factors. This one is a little bit more nuanced. Okay, so retroactive or regression is a return to a previous state. What does this mean from a biological standpoint? Again, we can talk about the cultural and the societal, the social evolution in that regard. But this is more, and this is different from countering. Countering is a massive outside force. Gradualism, there's a force that's been there, like, superimposed. The evolution is just, you know, it's impacted by the environmental settings. This is more so this is more so on the effect of what I talked about the return. This is a return to a previous state, maybe a reset, if you will. For example, let's say that again you had an isolated people group, and this kind of goes into the dominant and recessive, right? You had an isolated people group, and they developed certain types of ways, right? They developed certain types of ways, let's say genetically. Well, you introduce them. Let's say again, I talked about the mating of the horse and the wolf earlier, but let's just say in the case of let's say humans, where the dominant type of genetic aspect is reintroduced into the population in mass. You know, let's say if you have the Scandinavian Germanic tribes, right? Germanic tribes may have had some of the more dominant traits in humans reintroduced into a population. What are you going to start seeing? You're going to see the dominant traits take over. Now, you're still going to see a lot of the recessive traits, but this is where you have the survivalism kind of aspects. Not going too in depth in this video, but white supremacy and white survivalism, for example, or ethnic survivalism. This is where this kind of stuff comes from because people are concerned about being wiped out. Their specific factors being wiped out. Okay. This is where the much darker genetic aspects, the social Darwinism, the eugenics, and these kind of things actually occur. And again, we can deal with that in another video, but this is the factor that kind of dictates these kind of things. Yes, the dominant and recessive, but without this aspect, that stuff doesn't matter. People just be like, because from a eugenicist standpoint, that isn't like I'm highly opposed to eugenics, but eugenics in this regard, I appreciate if it's the best genes being passed on, we don't care. We literally want the best being passed on. It's like breeding for certain animals, dogs and whatever. You want certain breed, but you don't like have overly controlled. And again, we can talk about that and maybe in the ethics and the morals behind breeding. But this is the aspect of there's a certain type of thing, going back in time or return to a specific way. And you can go, and I mentioned about that, but it can also go in, maybe there was a genetic abnormality that occurred in one generation. And they're like, yeah, we're not doing that. We're going to do our best to return to a previous state or a state that worked for us. Okay. So it's a very controlled kind of aspect, whether people think about it or not. Take that with what you will. And again, if you want me to do an entirely different video, we can do that, and I might do that anyways. Lastly, number 10, pioneering, complete deviation. Again, we can talk about, okay, pioneers. We think of pioneering with, producing something new, producing, this is like progress potentially on steroids. I've talked about some things in the Jurassic, the counter being the drastic, the stagnation being the drastic, the kind of in this one the rarities being the drastic, the retroactive being the drastic, the mutation being the drastic. About half of this stuff are kind of more so accelerated or largely if we took like skill sliders on in like games, these are like setting some of these way over here as opposed to just kind of like minimally doing things. So this one is more so, what is it, pioneering? If let's say a species traveled, to a different area and set up shop, right? That's going to be massive towards how it infect. You've went into an entirely different environment, and you have to be learned how to survive. Initially, some are going to doubt because they're adapted to only that type of environment. This isn't that slow. This is like the shock treatment. If you just throw something or just throw something into the deep end and say, here you go, just survive it. Kind of like if you think of the ancient Spartan boys, where it's like at 7 or whatever, you just got to go survive. Or the rites of passage that certain tribes would use, where it's a young man kind of thing, and it's like, we're sending you off into the jungle or the woods. Good luck, kid. You come back, you're a man. We come back, we know you're good for the tribe and you can survive in these kind of environments and conditions. But take that on a massive scale. Take that, let's say, you've seen movies like, I don't want to even say, well, there is Ice Age, but these different movies where the long travel, it's in me on my way, long travel and introduce into that, and then boom, that changes. Or let's say complete germination. Let's say maybe there was bioengineering, right, for humans, and you've developed a new certain type of thing. Well, that genetic deviation is an introduction into the gene code that we don't know what's going to happen. Or let's say oil spills. Okay, oil spills happen We don't know what's going to happen within the next 1 to 5 generations or the next 50 to 100 years. We don't know what that's going to affect with the species that come out of that major event. That's a counter, but that's a counter event that has such a long-term ramifications or such a drastic ramifications that boom. This is more so, and I mentioned like the meteorite hitting. That's a drastic aspect of that. That's kind of why I use that. You can in your mind go, whoa, volcanic activity, not just like in certain volcanoes in Hawaii. Like if I want to say the super volcano in Yosemite, not Mount Silent, is it Yosemite? Is there a super volcano in the United States that's dormant? And if that went off, pretty much a third of the United States and Western United States are pretty much fucked. They just like there's nothing you can do. Or if Mount Fuji ever went off in Japan, yeah, that's a massive event. If a Category 5 storm comes through, that's usually a massive event. That's just like boom. Those are counter events, but in conjunction, you could have a pioneering type event like that. It's just usually that's more of a voluntary or pseudo forced one as opposed to just like like a massive event. More so, this is just there are so many factors that are being changed more than just a phenomenon happening. I hope I kind of got through with that one. I think y'all understand. Unexpected one to like, comment, subscribe. I knew this video would be a little bit longer, but I like having these discussions because too often stuff is stale. Too often people don't want to have an honest, in-depth take on matters. So, all right, y'all. Till next time, have a beautiful day, beautiful night. Let me know if you want me to continue talking about some of these other factors. Like I said, I will be talking about another evolutionary video and with survival and stuff later. But if you want me to talk about more in depth with some of these topics, we can get into it because this is kind of a general overview. Like I mentioned, like symbiosis there's about like 6 to 8 other like factors, and that most of them aren't even really talked about with biology. So yeah, and we can talk into social evolution and things like that.